The base of a reciprocating internal combustion engine is the engine block, which is typically made of cast iron or aluminium. The engine block contains the cylinders. In engines with more than one cylinder, they are usually arranged either in one row, straight engine, or two rows, boxer engine or V engine. 3 rows are occasionally used, W engine. In contemporary engines, and other engine configurations are possible and have been used. Single-cylinder engines are common for motorcycles and in small engines of machinery. Water-cooled engines contain passages in the engine block where cooling fluid circulates, the water jacket. Some small engines are air-cooled, and instead of having a water jacket, the cylinder block has fins protruding away from it to cool by directly transferring heat to the air. The cylinder walls are usually finished by honing to obtain a crosshatch, which is better able to retain the oil. A too rough surface would quickly harm the engine by excessive wear on the piston. The pistons are short cylindrical parts which seal one end of the cylinder from the high pressure of the compressed air and combustion products and slide continuously within it while the engine is in operation. The top wall of the piston is termed its crown and is typically flat or concave. Some two-stroke engines use pistons with a deflector head. Pistons are open at the bottom and hollow except for an integral reinforcement structure, the piston web. When an engine is working, the gas pressure in the combustion chamber exerts a force on the piston crown which is transferred through its web to a gudgeon pin. Each piston has rings fitted around its circumference that mostly prevent the gases from leaking into the crankcase or the oil into the combustion chamber. A ventilation system drives the small amount of gas that escape past the pistons during normal operation, the blow-by gases, out of the crankcase so that it does not accumulate, contaminating the oil and creating corrosion. In two-stroke gasoline engines, the crankcase is part of the air-fuel path, and due to the continuous flow of it, they do not need a separate crankcase ventilation system. The cylinder head is attached to the engine block by numerous bolts or studs. It has several functions. The cylinder head seals the cylinders on the side opposite to the pistons. It contains short ducts, the ports, for intake and exhaust, and the associated intake valves that open to let the cylinder be filled with fresh air, and exhaust valves that open to allow the combustion gases to escape. However, two-stroke crankcase scavenged engines connect the gas ports directly to the cylinder wall without poppet valves. The piston controls their opening and occlusion instead. The cylinder head also holds the spark plug in the case of spark ignition engines and the injector for engines that use direct injection. All engines use fuel injection, usually direct injection, but some engines instead use indirect injection. SI engines can use a carburetor or fuel injection as port injection or direct injection. Most SI engines have a single spark plug per cylinder, but some have two. A head gasket prevents the gas from leaking between the cylinder head and the engine block. The opening and closing of the valves is controlled by one or several camshafts and springs, or in some engines, a desmodromic mechanism that uses no springs. The camshaft may press directly the stem of the valve or may act upon a rocker arm, again, either directly or through a pushrod. The crankcase is sealed at the bottom with a sump that collects the falling oil during normal operation to be cycled again. The cavity created between the cylinder block and the sump houses a crankshaft that converts the reciprocating motion of the pistons to rotational motion. The crankshaft is held in place relative to the engine block by main bearings, which allow it to rotate. Bulkheads in the crankcase form a half of every main bearing, the other half is a detachable cap. In some cases a single main bearing deck is used rather than several smaller caps. A connecting rod is connected to offset sections of the crankshaft, the crank pins, in one end and to the piston in the other end through the gudgeon pin, and thus transfers the force and translates the reciprocating motion of the pistons to the circular motion of the crankshaft. The end of the connecting rod attached to the gudgeon pin is called its small end, and the other end, where it is connected to the crankshaft, the big end. The big end has a detachable half to allow assembly around the crankshaft. It is kept together to the connecting rod by removable bolts. The cylinder head has an intake manifold and an exhaust manifold attached to the corresponding ports. The intake manifold connects to the air filter directly, or to a carburetor when one is present, which is then connected to the air filter. It distributes the air incoming from these devices to the individual cylinders. The exhaust manifold is the first component in the exhaust system. It collects the exhaust gases from the cylinders and drives it to the following component in the path. The exhaust system of an ICE may also include a catalytic converter and muffler. The final section in the path of the exhaust gases is the tailpipe. The top dead center, TDC, of a piston is the position where it is nearest to the valves. Bottom dead center, BDC, is the opposite position where it is furthest from them. A stroke is the movement of a piston from TDC to BDC or vice versa together with the associated process. While an engine is in operation, the crankshaft rotates continuously at a nearly constant speed. In a 4-stroke ICE, each piston experiences 2 strokes per crankshaft revolution in the following order. Starting the description at TDC, these are 8, 9. Intake, induction or suction. The intake valves are open as a result of the cam lobe pressing down on the valve stem. The piston moves downward, increasing the volume of the combustion chamber and allowing air to enter in the case of a SI engine or an air-fuel mix in the case of SI engines that do not use direct injection. The air or air-fuel mixture is called the charge in any case. Compression. In this stroke, both valves are closed and the piston moves upward, reducing the combustion chamber volume, which reaches its minimum when the piston is at TDC. The piston performs work on the charge as it is being compressed. As a result, its pressure, temperature and density increase. An approximation to this behavior is provided by the ideal gas law. Just before the piston reaches TDC, ignition begins. In the case of a SI engine, the spark plug receives a high voltage pulse that generates the spark, which gives it its name and ignites the charge. In the case of a SI engine, the fuel injector quickly injects fuel into the combustion chamber as a spray. The fuel ignites due to the high temperature. Power or working stroke. The pressure of the combustion gases pushes the piston downward, generating more work than it required to compress the charge. Complementary to the compression stroke, the combustion gases expand and as a result their temperature, pressure and density decreases. When the piston is near to BDC, the exhaust valve opens. The combustion gases expand irreversibly due to the leftover pressure, in excess of back pressure, the gauge pressure on the exhaust port. This is called the blowdown. Exhaust. The exhaust valve remains open while the piston moves upward, expelling the combustion gases. For naturally aspirated engines, a small part of the combustion gases may remain in the cylinder during normal operation because the piston does not close the combustion chamber completely. These gases dissolve in the next charge. At the end of this stroke, the exhaust valve closes, the intake valve opens, and the sequence repeats in the next cycle. The intake valve may open before the exhaust valve closes to allow better scavenging.